Since we already established a fact that if I want to convert galvanometer to ammeter, I need a low resistance shunt in parallel. And if I want to convert from galvanometer to voltmeter, I need a high resistance multiplier in series. This is all I need to get the formula. So how do you now get the formula for all of them? Now let's go. Very easy concept. Now, if they are connected in series, in parallel, the number one thing is that the current I total, right, will be summation of what will be in the galvanometer plus what will be in the shunt. Don't forget, galvanometer to ammeter, abi? Yes, so the shunt. This is what will happen. But the voltage in the galvanometer will be the same voltage in the what? In the shunt, because they are connected in what? Parallel. Yes, they are connected in what? In parallel. Very important. So this one, the first case is galvanometer to ammeter. I don't know why you guys cram it. So that means this is all I need. This formula is what I want to get for you now. This is the statement I need. So since I know this and I know this, that means I can say V equals to what? IR. This is the formula that most of you cram. I did not cram it. V, that means this is what? IG times RG. Abi equals to IS times what? Times what? RS. That means this is what I'm looking for, because that's the resistance. That's the low resistance shunt that is connected in parallel. That means RS is what I'm looking for, which will be equals to what? IG RG over what? IS. So this is the formula you need. Now, why do I tell you this? IGIS. Now, so if I, from here, I can see I total, IGIS. So I can always alter this. But this is the formula you need. So this is when I'm converting galvanometer to what? To ammeter. Very important. Very simple question. Very simple. So if you know this formula, this one is in your new school physics, but you don't need to cram it. That's why I'm teaching you like this. So what are the statements that you need? First thing is that they are connected in parallel. And if something is connected in parallel, their voltage is the same. And their currents will be different. And if the current differs, it means the total current will be the summation of the current that will go through the galvanometer and that will go through the shunt. So that's all you need. That's the statement. I'm purposely waiting so that you write this thing down. This one. So, in fact, this is all you need, sir. This one. But it's because of explanation. So, VG equals to VS. Okay, are we good? Good to go, right? Very easy. So you don't need to cram. I hate people cramming things like this. So this is the first case, galvanometer to ammeter, low resistance shunt. This shunt is a what? Is a resistor. You understand? But it's of low resistor, but it was connected in parallel. You understand? So this is the first case. Let's go to the second case. If I want to convert, please take note of this. Okay, I'll write the formulas. Okay. So if I want to convert from galvanometer to voltmeter, G to V, we already established a fact that what will I need? High resistance in what? In series. This is what I need, series. So if they are in series, what happens to the current? We already established that the current total will be the same thing as the what? As the current that will pass through the galvanometer. You understand? It will also be the same thing as the current that will pass through the what? The multiplier. We already established this fact. Now that means if the current is the same, their voltage will differ. So that means V total is equal to what? The summation of the V that will pass through the galvanometer plus the summation of the V that will pass through the multiplier. Because this one, the voltage will be different because they are in what? In series. So from here, okay, let me just write it here. RS equals to IG RG over IS. That's G to A, the first equation. Now from here, you already got the answer. So that's why I told you how important, how profound that statement of saying if they are in series, their current is the same, voltage is different. If they are in parallel, their voltage is the same, current is different. So now from here, I can get all my answer that I need. How? This V total can be equals to what? IG times what? RG. Don't forget, we already established that V equals to what? IR. Abi? Plus IM times what? RM. The resistance in the multiplier. Abi? Now, don't also forget that this is what I need, right? This is RM that I need because I have to calculate the resistance in the multiplier. So that means I can tell you now, since this is what I need, I can say IM, Abi, times RM equals to what? IG times, sorry, if this is here, V total minus IG times RG. You will see more maths now. This is what I need, Abi. That means RM is like saying V total minus what? IG times RG all over what? I N. But we made a statement. What is the statement? I total is the same thing as IG is the same thing as what? I M. So the current that will be here is also the same thing as current that will be here. So what do I need to do? I'll just say everything, since the current is the same, I'll just say, oh, I don't need the M. So what the current that they just gave me is sufficient because they are connected in what? In series. So this is the second formula. So you don't need to cram. What do I need to know? This is all I need to know. For what? For converting galvanometer to voltmeter. Abi? Very easy. Very easy. So this is converting galvanometer to ammeter. I need this formula. Converting galvanometer to voltmeter. So I'm not saying you should cram this. Don't even cram this one. Just know this. Once you know this, you understand the concept and you understand this principle that we have been explaining. These principles, they are very, very important. So let me give you a question. This is a question in JAMB. So let me give it to you. So before we the JAMB question, you are writing JAMB, you are a JAMB candidate. So you are a JAMB candidate, move closer, okay? So they will ask you that calculate the resistor of the multiplier now. If the potential difference is 50 volts, this is a JAMB question. I don't know how I still remember it, but I'm going to tell you it's a JAMB question. Potential difference. Now, of course, you know that the potential difference now is still V, is the V total actually. They will now say the current is what? 50 milliampere. Now, don't forget, milli is a sub, Abi. So, milli means 10 raised by what? 10 raised by minus 3. Okay, 10 raised by minus 3. If you have not subscribed, better subscribe now. Okay, subscribe, oh. Subscribe. I'm going to teach you a lot. I'm ready for you. Though I'm sweating. Oh, yeah, can you see? I'm sweating because of you. You must do well. You must score that 300. Yes, oh yeah, like. You have liked. Have you liked now? Okay, oh yeah. Comment. Have you commented? Good. Oh yeah, share to your friend. Share to your friend. I can't be sweating for only you. Let other people learn. So that means I can tell you that this current means 0.05 ampere. What do I need again? Now they will now give you the resistance of the galvanometer here. So let's say the resistance is 5 ohms. Okay, yes. Now you'll be why do it's just one current that they give me? Yes, it's one current. We already established the fact that IG is equal to IM, so it's also the I, so that's the current here. RG is 5 ohms, V total is 50, then RM. Oh yeah, solve the answer in the comment section. I'll pick the first 50 correct answers and I will see the first 50 persons that will get this question because it's very important question. Yeah, I know the answer to this question because it's a JAMB question. It's in your JAMB pack. So I will know those that follow. But yeah, drop. What is the resistance? And they must be connected in what? I already told you. In what? In series. Abi? So don't let my sweat go in vain. Yeah, thank you so much. God bless you. So see you in the next class. If you have not subscribed, okay, let me leave. If you have not subscribed, do so now to support me. Share to your friends. I'll be teaching you a lot before for the next 40-30 days to your jam. I'll be teaching you. But if you want to join our class where I'll be teaching you in a closed WhatsApp group, you can send me a DM, and your jam is in trouble. I'm going to you're going to do well. Okay. Bye for now. Know this: galvanometer to ammeter, galvanometer to what? Voltmeter. Know this: galvanometer to voltmeter. So catch you later. Bye for now.